Since we're now pros at this, right? Since practice makes perfect, we could do this quick enough, right? So, boom, what do we see? Where the first partial be, right? We have x here, no x here, x here, and no x here. So we're only looking at this and that. So the partial would just be 3x squared, and this one would just be negative 300, right? And for y, we see no y here, we see a y here, no y here, we see a y here, no y. So we look at this and that. So what do we get? 3y squared minus 75, right? So this is a good thing because we have one variable on each equation, right? Only x here and only y here. So let's solve that, right? So 3x squared minus 300, right? Equals 0. Let's just simplify that, right? Equals 300 divided by 3. So x squared equals 100. So overall x equals plus or minus 10. And right here, we just simplify that to 3y squared. Move the negative 75 to the other side, making it equals 75. Divided by 3 again, right? And what do we get? What's 75 divided by 3? I believe it's, what's one we're doing it? 224. Use my calculator. We get 25. I should have knew that. It's quarters. 3 times 25, 75 cents. So we have y squared equals 25, and limiting the square, we just do y equals plus or minus 5, right? So this will be a big one because since we have plus and minus on both, we have 4 possibilities. So we have 10, 5, right? 10, negative 5, and we have negative 10, 5, and we have negative 10 and negative 5, right? So after that, we find our second partials. So we have fxx just equals to 6x, right? That just equals to 6y, right? And this, what would that equal to? Nothing, so 0. So that kind of relieves us more work, so we only need to care about d is equals to 6, right? 6x times 6y. Just since this is 0, we don't have to worry about this at all. Okay, so what's 6 times? Let's do at corresponding order. So this is 1, 2, 3, 4. So at 10, 5. 6 times 10 times 6 times 5, we get 60 times 30, right? That equals 1800. So our discriminant is greater than 0. And looking here, the f of x, right, is greater than 0, right? We have, and so therefore that row is local min. Right here, we have points at 10, negative 5, right? So we could just do that in our head, right? So 6 times 10 is 60. Negative 5 times 6 is negative 30. So that would just give us negative, right? Negative 1800. But our f of x is still positive, right? Because 60. So it's a, oh, sorry. We don't have to care about the rule because if it's negative 1800, d is less than 0. Therefore, no matter what, it's a saddle point. Let's do SD for saddle point. Going down here, we get 6 times negative 10, right? And 6 times 5, right? 30. So negative 60 times 30 is still negative 1800, right? Because that's the saddle point. And going last but not least, we have negative 10, negative 5, right? So we get 6 times negative 10 is negative 60. We have negative 5 times 6, that's negative 30. So positive times a positive equals to, oh, a negative times a negative equals to a positive, right? So that would just be 1800. But our x equals negative 60, right? So that's less than 0. So our d is greater than 0, but this one is less than 0. So what do you say? That's local max, right? So at point 10.5, we get local min. At point 10, negative 5, we get a saddle point. At point negative 10.5, we get a saddle point. And at a point negative 10, negative 5, we get a local max. So going on, we get this right here. So we have 325. In the textbook 325, still asking the same thing. So our partial, right? There's no x here, we have x here, so we just get negative 4x to the y to the fourth power, right? And to the y, right, we get what? Nothing here, so that'll be negative 4x 4, right, to y to the third power. So overall, we both equal them to 0, right? So seeing this, I say that, to the third, fourth, the critical point would just be 0, 0. And that's all we get, right? So let's find the second partial, right? That just equals to negative 12x cubed, x squared, right? To the y. Since it's constant, y to the fourth, and we need to find this. So that would just be negative 12x to the fourth y squared. And this one is negative 16 x cubed y cubed, right? So finding at point 0, 0, we get d is equals to negative 12 times 0, right? Squared times 0, 4 minus 12, 0 to the fourth, and times 0 squared, right? Minus, right, negative 16, 0 to the third, and 0 to the third here, right? So overall, d equals 0 is inconclusive. So during the test, we go back to the normal function, right? Which is 9, right? Minus x to the fourth, y to the fourth, right? So we just bring this over to see what will happen. So negative x fourth, y to the fourth equals 9, right? So looking at that, whatever you do in plug in points, it will never go over 9, right? No matter what we plug in, it will never go over 9 because this right here. So overall, this is the max. And finally we have 333. Now we are dealing with this. It looks hard because, I don't know, do you think it looks scary? So let's try doing it. So we have this function, right? What do we do? Since this is not cannot be differentiated, right? We just, leave this as it is, right? But we just have to look at this function, right? So looking at that function, let's do it here. We find a partial, negative partial, right? Of x squared plus y squared plus 2x, right? Finding that, we just get 2x, this goes nothing, and we have plus 2, right? So overall, we have this. So negative 2x is right here. So it would be negative 2x plus 2 times e to the x squared plus y squared plus 2. Now we find the partials to y, right? Same thing applies. This is not differentiated. You can differentiate this. And we go look at this function, right? So what do we get? We have a y here, but no y is here, so we get this 2y. So our partial to respect to y is 2y e to the negative x squared plus y squared. Oops, this should be negative. Y squared plus 2, right? So now after that we set the partial derivatives to 0 to find the critical points, right? Since, this is a big hint, e squared plus y squared plus 2x does not equal 0, we have this 2x plus 2 equals 0 and 2y equals 0, right? We're looking at these right here. that makes it super easy for us. So overall we have 2x equals -2, we have x equals -1, right? From here, divided by 2, we have y equals 0. So overall, our only critical point is -1, 0, right? Now we find the partial, the second derivative test, right? So the second derivative, right? Oh, it's gonna be a lot. But good thing I did this beforehand. So you could do that, but I'm going to tell you what the answer is. We get -2e to the negative x squared plus y squared plus 2x plus 2x plus 2 square e x squared plus y squared plus 2x. And for the y, we have oh, not for the y, we still could go find that even more. E to the x squared plus y squared plus 2x times -2 plus 2x plus 2 squared, right? So let's evaluate the point of -1, 0, right? So overall, we have -2, right? Just plugging in -1 and 0. So let's find the partial to y, which is final answer is just e x squared plus y squared plus 2x, then just times -2 plus 4y squared. We evaluate that at -1, 0, and that equals -2. Now we find the mixed partial, right? Overall, for the mixed partial, we get -2x plus 2, -2y to the e of -x squared plus y squared plus 2x equals 0, and we evaluate that, right, at -1, 0, right? So overall, it would be simple. See right here, so that actually equals 0. So our equation, right, is basically d equals to -2 times -2, right, minus 0 squared. So that just equals 4, right? Since d is greater than 0, right, but our double partial, right, respect to x is -2, so less than 0, we have our answer at point -1, 0 is a local max. So overall, we're done with this video. Give yourself a star. King hat. We did it. Fireworks.